Okay, so we're going to try and do your notes digital for a while to see how this works out. And we'll start with Unit 7, finding volume, filling and wrapping. So we're going to be filling items and wrapping them. So filling is volume and wrapping is surface area. We're going to do an introductory section with investigation 1.1, 1.2, and 1.3, finding volume, optimal containers, and surface area, and a continuation of finding the best containers, finding the least surface area. They all really go well together, so we kind of do them all at one time. Continue on to the page numbers that you're currently on. I don't have my notebook with me at home, so we'll fill this in according to your last page number. Just continue on to your next page. If you need to, pause the video, write this down in your table of contents. There should be no missing items in your table of contents. Okay, so pause the video as you need to, fill this in, and once you're ready, go ahead and move on. So today's March 2nd. We are doing 1.1 all the way to 1.3. We're just going to do one focus question. Make sure you put the date, the title, and the page number. Our focus question is, how can you find the volume, okay, and surface area of a rectangular prism? What dimensions of the same volume will have the least surface area? So this second question pertains to 1.2 and 1.3. The first one talks about a little bit of everything. I underlined and color coordinated these as new vocabulary words: volume, surface area, and prism, and I wrote them down here. Before you start copying them down, leave a little space after each one. We're going to draw something in here so you can see what it looks like. Okay, so volume represents the amount of space an object occupies, the amount of space it takes up. So when you think about a flat piece of paper, it's got a very, very low volume. It's more two-dimensional. Once that piece of paper, once you start layering stacks and stacks and stacks of paper, if you have like 1,000 sheets of paper, then it starts to take up a lot more space. Its volume increases. So volume is gonna take up space in a room, whereas surface area will just cover around the room. Okay. So before we move on to surface area, I'm gonna visualize volume for you. Okay. So this is the virtual box. And I'll post a link of this on the Google Classroom for you, so you can take a look and play around with it a little bit. Now, volume represents everything inside here. So what can fit in here is going to be volume. So the part that I'm unfolding here, that is what we call surface area. That's the outside version. Okay. Now, volume is represented by these blocks. So how many blocks or how many units will fit inside? So far I have 20 blocks. 20 blocks inside there. Well, how many can I fill until this box is full? The amount of boxes in here is my volume. Okay, so I have a total of 60 boxes. You see how this went gray? I can't put any more in. Okay, now if I undo this, let's go back a little bit. Okay, I have 60 boxes total that will fit here. This bottom layer is represented by 20 boxes. Okay, 20 boxes. So if this bottom layer is 20, how did I get 60? I added another layer, so that's 20. I add a whole nother layer, that's 40. This represents one whole layer, and one layer represents 20 boxes. And one more layer on top of that. 20 there, 20 there, and 20 there. I can't put any more in. Okay, so the amount of items inside is volume. And we represent that using our width, our length, and our height. Okay, so I'm going to take a picture of this and we'll move this into our and we'll put this into our notebook. A little bit of a sketch. We don't have to fill in and draw all these little boxes, okay? So let's go back to here in our notes, and I'm going to draw so you can see what I'm drawing here. So I'm going to use this. Okay, so the amount of space something takes up. Okay, so I'm gonna do a length, and then I'm gonna go a width, and I'm gonna do a height. Okay, those three objects. Like, well, Mr. P, that's not really a volume of any sorts. Well, actually, what I'm gonna do is I'm gonna use these three items and just duplicate it, because there are two sides to this one. Okay, this one I'll draw again, and it's really hard to use this drawing pad well, so I'm just gonna use the height 4 times. Okay, so move this down a little bit. Okay, these are all represented by the same value. Okay, my width is the same each time, and my height and my length are the same each time. So this is going to represent my volume, how much space something takes up. Okay, it's three-dimensional. To calculate volume, okay, it's going to be width. Let's write that out so we know what it is. Width times length times height times height. Let's get this over a little bit. I'm running out of space. Times height. Okay, and all that equals volume. Okay. This equation will equal volume. Okay, very important equation to know. Now you might also see base times height. Your base is just length times width. This portion here is your base. Okay, so you see base times height, this represents base. Okay, width times height is your base. Sorry, width times length is your base. Okay, surface area. So let's go back to our box, see what that looks like. Here's our box. Okay, when I clear my box, the amount of wrapping paper around my items is my surface area. So what I'm just going to sketch that out for you so you see what it looks like. Okay, so this length, okay, and again I'll do my width or my length and my height. Okay, I'll do the same thing. I'll just try to make it a little smaller. Okay, and I'm going to see if I can get this to look like a rectangle so you can see where all the points are represented. Okay, this one. Okay, that's the bottom. Okay, when I lay it out flat, this one, okay, will become the sides. Okay, when I open it up, those are the sides. Again, I have to move this up so I can get it to fit. Okay, these two put down here. Okay, those are my heights. Okay, and then the lengths here are actually these as well. That's the height of the box. Okay, and the top, across the top will be this one. Okay, and this one goes there. So it'll look like this. It'll look like a big T. Okay. And then on the other side, on the top side, will be this one again. These two. This is the top when it's laid out. Okay. And then these two over here. Should go here. So when you open up the box, okay, and you split open a box, you get all these different parts, okay, and I'll label each one, okay, so this one is the bottom. You know what, let's make that pen a little bit smaller, a little bit thinner. This is the bottom, and this one is the top, Okay, the bottom and the top, they're the same. Okay, you see a box, the bottom and top are exactly the same. This is the front, and this is the back. They're the same piece, and this is the left, and this is the right. And those pieces are the same. Okay, so that's our surface area. I'll write the equation out for you guys in a second. I'm just going to pause the video because I don't want this video to go over. Okay, so here's your equation, and the key to it is not memorizing it. If you try and bank on memorizing this, you will have a really hard time. You need to know that you're going to be adding each of the parts together. So just identify what each of the parts represent. The top and the bottom are the same, the left and the right are the same, and the front and the back are the same. If you think about a box, if you think about, I don't know, a cube, a dice, there are 6 sides to a dice. You can think about what each side represents. Okay, so the length and the width. So if I think about length and width, okay, that's the top and the bottom. So this is my top and bottom. Okay, top slash bottom. Abbreviate. Length and height. Length and height, that's left and right. Left. Oops, what the heck? Left and right. And the height and the width, this is front and back. Okay. Now the reason why it represents 2 is because there's 2 of them. There's a front and the back. There's the top and bottom. There's a left and right. That's why it's times 2. Okay. So, and when you get each part, you end up adding them all together. Here's the top and the bottom. I add it to the left and the right. I add it to the front and the back. Okay. So understanding what it is better than memorizing it. Okay. It's better than memorizing. Okay. A prism is a solid geometric figure whose base is repeated over and over and over again to create a 3D shape. We've already worked with prisms. Okay. So a prism looks like this. Here's the base, and it's repeated over and over again. That's it. So when you can have a triangle that's repeated over and over and over again. You can have a circle that's repeated over and over and over again. You can have a you have any shape, a pentagon that's repeated over and over again. That is a prism. So prism is a shape that has a base. The base will look like any shape you want. That could be a triangle, it could be a pentagon, hexagon, whatever. And it's repeated over and over and over and over and over and over again until it makes a repeated version of itself. The sides of a prism should all be rectangles. Okay, so I'm gonna put this into here. I'll draw a quick sketch. Okay, so my sketches always come in different shapes. So I can have something like a triangle, and then I can repeat this triangle over and over again. Okay, and I repeat it over and over again, and I connect the 2 dots with a line, 2 shapes with a line, and I'll have a prism. Okay, that is a prism, triangular prism. Okay, you can have any shape you want that makes a prism. You can have a pentagon. Okay, and if you repeat the base, that's my base, and I repeat it over and over and over again, and I connect the dots again, I will have a prism. This line to that line, this line to that line, etc. This one to that one. Okay, this makes a prism. Okay, it's a shape that's repeated over and over again. Lastly, your lab sheet will look like this. Okay, I kept the same title because it's the same section. So you're gonna glue this into your notebook, cut it out, glue it into your notebook. Okay, and we'll work with 24 cubes. Okay. Every pair of you guys or every table will get 24 cubes. Okay, this is going to your notebook, and we'll work on this together as a class. Okay. Okay, just kidding. After you paste this into your notebook, either on the next page or the bottom of the page, I want you to do these 3 things. 1, you can write a summary. In 3 sentences or more, describe what you've learned from this video lesson. What surface areas, etc. Really quick. Question, write down any questions you may have, so that way it's fresh in your mind, you'll forget them. And lastly, check up question, find the volume, and this surface area. Show your work.